Hey everyone, this is Daniel Frank's presentation on Bedquilt. This is going till about 3:15. Oh no, it's mostly virtual. I believe there should be some Q&A towards the end, but yeah, everyone get settled in and enjoy.
Right. So this is a talk on Bedquilt. It's the parser-based IF engine I have in development. The structured part of this talk will be fairly short, shorter than I advertised, because I realized that there are a lot of things about the system I could talk about, but I'm not sure which ones are actually going to interest people. So I've prepared structured content on just the basic motivation and core technical decisions of the system. And then after that, since we have a fairly small audience here, the few, the proud, the hardcore parser-oriented geeks, we can just let Q&A drive what we discuss from there. So one of my favorite things about parser-based interactive fiction is the flexibility and predictability I have in the user experience. Whatever device I want to play it on, I have a portable game binary, be it Z Machine or Glulx or TADS or whatever it is, and I can plug it into whatever interpreter fits my needs and the needs of the device that I'm playing it on that time. I can play it inside a terminal window. I can play it on my phone. I can play it in my browser, and just every time I get a predictable user experience, that's exactly as I want it to be. I can plug in whatever GLK engine fits my needs at that time. On the other hand, the developer experience for parser-based interactive fiction is not so flexible. If I want to target Glulx, for example, right now without Bedquilt, Inform is my only option. There are Glulx is not the only choice, of course. TADS has its own VM. A lot of other interactive fiction development engines all have their VMs as well. But every one of these VMs and every one of these languages is specific to developing for interactive fiction. If I want to develop in an ordinary mainstream programming language, there's nothing out there that allows me to do that, and also provide this wonderful flexible user experience that I just raved about. And because of that, we lose out on a lot of things. If we're using a domain-specific language, then everything we want to build to support that language is something that we need to develop within the community. So Inform has an IDE, TADS has an IDE, but every feature that we want to build into that IDE is something that the community itself needs to build. Whereas if we're building in a mainstream programming language, then we're getting all that we're getting all that from outside developer communities free of charge. We don't need to develop anything special for interactive fiction. So along with IDE support, we get mature package ecosystems. We get tool ecosystems. We also get in the current year the ability to vibe code things. So LLMs are especially good at writing in JavaScript and writing in Python. They're pretty decent for any other mainstream language, down to something as obscure as, say, Haskell. After that, they get pretty useless. I wouldn't ask an LLM to write TADS code for me. So just some historical perspective as to how we got into the situation where we have special languages for IF, we have special interpreters for IF. So history really started with the first parser games, Colossal Cave Adventure and Zork. So Colossal Cave Adventure was originally written in Fortran. which is and mainframe Zork was written in something called MDL, which stands for more data types than Lisp, but it was basically a Lisp-like language. So the authors of Zork founded Infocom, and so they wanted to commercialize this game that originally ran on an MIT mainframe, but they wanted users to be able to run it on the microcomputers that existed in 1979, which were quite tiny. So the original Zork was for mainframe was all one game. It got broken into a trilogy, not for narrative reasons, but because the game was too big to fit on the machines at the time. So MDL it was a big featureful language for mainframes that they'd already written in. So what the Infocom founders did is they designed the Z machine, which was a high-level VM just precisely tailored to what they needed in order to fit in order to fit the Zork game onto a variety of microcomputer architectures, and then around the Z machine, they designed ZIL, which was just a language that's superficially like MDL, Lisp-like, but doesn't really have very many of the helpful features that you would find in a Lisp. But it was something that's easy to rewrite Zork into, and was tightly coupled and nicely tailored to the Z machine they designed. This model took off. Z machine interpreters proliferated, and then finally, after the fall of Infocom in 1993, Graham Nelson designed Inform, again targeting the Z machine, but those same features of the Z machine drove a lot of design choices in early versions of Inform. And then the last episode of the saga comes in 1999 when games started outgrowing the Z machine, and so Zarf created a brand new virtual machine called Glulx and ported Inform to it. So here's what Zarf wrote about Glulx in 1999. He called it a simple solution to a fairly trivial problem. But it turns out, so Glulx is despite the domain-specific nature of the problem, Glulx is actually a very clean, very general VM that I actually consider better designed than any of the much more professional things that already existed at the time. And it actually took a long time since 1999 for anybody to create an altogether better design, whether for the purpose of writing parser games or for anything else. So meanwhile, in a parallel universe, there's a pretty similar saga played out in a much more mainstream setting, which is that Netscape wanted to be able to run dynamic content in their new browser, and so in order to do that, they kind of bet on two horses at once. First, they collaborated with Sun to create Java applets, and secondly, they hired Brendan Eich to embed Scheme into the browser. Later, the decision to use Scheme got vetoed, and they told Brendan Eich to invent something new instead of using Scheme, and so he did and called it JavaScript. Early JavaScript was a pretty simple affair. The kind of things that they were trying to run in the browser in 1995 were not very ambitious. But all of that changed in 2004 when the Web 2.0 phenomenon happened. They pushed things developers push things far beyond the original vision that JavaScript was designed for, and so a lot of work got done to turn this kind of janky language that was early JavaScript into something much more robust and just that serves the needs of modern web apps. But nonetheless, people were pretty unhappy with being tied to JavaScript anytime they want to develop for the web. And so in 2013, this new effort started called ASMJS, and this was basically a path out to solve the chicken and egg problem to get widespread browser support for a web development language that wasn't JavaScript. And the way they did that is basically ASM.js was fundamentally a low-level virtual machine bytecode, but syntactically it's a subset of JavaScript, and it can be executed by a JavaScript interpreter. But if you know that what you're speaking is not full JavaScript, it's actually ASM.js, then you can target that from a general purpose programming language, and you can write an efficient compiler for it that'll turn it into native code. This was and then building on the early technical successes of ASM.js, we broke away from that, created something entirely new, and that something was called WebAssembly, and that is at last the robust and portable bytecode assembly we've been wishing for decades. And in my opinion, until WebAssembly, for 18 years, I suppose, Glulx was really the closest thing that existed anywhere to fulfilling that vision, which is kind of funny in my opinion that we've got this obscure little backorder community creating parser-based IF. But we really had we really had the best tech out there for this highly applicable general problem, and it's quite remarkable to me that it took that long for anything else to catch up. So Glulx and WebAssembly, in both cases, we have these simple, elegant 32-bit stack machines. In the case of Glulx, you can compile from Inform and then run anywhere. In the case of WebAssembly, you can compile from a large number of different mainstream programming languages, from C, from Rust, from Go, and then again, once it's compiled to WebAssembly, you can plug that into a variety of interpreters or compilers that'll make it run anywhere. But in the case of Glulx, we've got no compiler except Inform that will target it. And in the case of WebAssembly, we've got a lot of compilers, but what we don't have is IF interpreters that accept WebAssembly, and therefore you don't get that beautiful user experience that I introduced the talk with, without having to do a lot of new development to push new software onto users that it's not clear in the absence of games to target it yet why they would want to install that. So to bridge this gap, one hacking binge later, I created Wasm to Glulx, which is exactly what it says on the tin. You can write in any high-level language, compiled WebAssembly, and then WebAssembly has the concept of imported functions, which you can think of it as your system API. So WebAssembly runs inside your browser. It can import and call functions that are written in JavaScript. JavaScript can in turn call the DOM and receive user input or put things on the screen. In the case of Wasm to Glulx, instead of importing JavaScript functions, you're importing the GLK API. So you can run that compiled WebAssembly module through Wasm to Glulx, and what you get out is a Glulx story file that will run seamlessly on any existing Glulx interpreter. So as a proof of concept for this, I ported OpenAdventure. So OpenAdventure is a version of Colossal Cave Adventure, which has an interesting lineage. So Crowther and Wood's original adventure was originally written in Fortran. They originally wrote the 350 point version, which is best known. A bunch of people expanded on it. Crowther and Wood's own expansion, and kind of the final version by the original authors, is the 430 point adventure, which was I'm sorry. Which is again still written in Fortran, but in I think like '97, Don Woods ran that Fortran program through an automated translator that turned it into C and posted those C sources to Usenet. And then Eric Raymond contacted Don Woods and persuaded him to place those sources under a BSD license. What he then did was take those mechanically generated C sources, which being generated code are ugly to read and even uglier to maintain. But they do run. He wrote an extensive test suite to verify the existing behavior of that code, and then progressively refactored that code into readable, modern, maintainable C code, but at every step of the way, studiously maintained the original user visible behavior of the adventure sources from 1995. So he released that, and then I forked Open Adventure simply by taking all of the I/O functions that call into C Studio and replacing those with Glulx I/O with calls into the GLK API. Ran that through Wasm to Glulx. And sure enough, the thing worked, and so we now have in a Glulx interpreter, you can download. This is up on the IVE archive. You can download and try it out. A version of Adventure, which unlike other Glulx versions, is not the rewrite and inform. It has this direct lineage to Crowther and Wood's original version, and I think it's pretty cool that this actually ran, and it ran surprisingly well, because Wasm to Glulx has a very thorough test suite, which I was able to auto generate by taking the Bytecode Alliance's original validation suite for testing that your WebAssembly implementation conforms to the spec. Mechanically converted those into unit tests for Wasm to Glulx. This led to the discovery of several bugs in Glulx interpreters along the way. So that was fun, because I've twisting the Glulx interpreter in new ways that had never been exercised before. But once my code had been exercised by this test suite, the first non-trivial program that I ran through it, which was Open Adventure, pretty much just ran. The only bugs I had on my first attempt were things related to my GLK bindings, which of course the Wasm test suite wouldn't cover. So next thing, this is supposed to be a hyperlink. Oh well, I'll have to get that in manually. Yeah. So while Wasm to Glulx is completely language agnostic, it'll run anything that has a WebAssembly compiler. From here on, the development I've been doing is in Rust, so nice thing about Rust is that its standard library is broken into three pieces. It has one piece called core, which are the things that don't have any operating system dependencies at all. They can run completely standalone. There's alloc, which is functionality that assumes you have a memory allocator but doesn't require anything else. And then finally, there's the standard crate, which is the things that which assumes that you're running under a traditional operating system. So if you're targeting Glulx, then you don't have that traditional operating system, but you can still use Rust's ordinary core and alloc crates. And then in addition to those, I've created this crate, Bedquilt IO, which is basically safe and idiomatic Rust bindings to the GLK API. So what we see here, this is kind of a hello sailor written in Rust to target Glulx. So this is just a simple Rust program that will read a line of input from the user, and then echo that back to the screen. So it's all based around async Rust, which is basically Rust's way of giving you green threads on whether or not your runtime is actually multi-threaded, which of course Glulx is not. But this is a convenience if you're developing any kind a game that does any I/O other than just interacting with keyboard input. For example, if you want to loop some background music, then this would allow you to have a dedicated green thread that will just handle audio events, and you can keep that program logic separate from your main game logic that has nothing to do with any of that. So it's a convenience that allows you to write cleaner code that separates concerns. So I've got a complete module system here. It gives fairly complete coverage of everything that GLK can do through a fairly idiomatic Rust API. Oops. Going back to slides. All right. So everything I've discussed so far, development is basically complete. The next thing next piece where development is still ongoing is Bedquilt's database engine. So text adventures need something that kind of resembles a database, just to keep track of saved game state. In the ordinary way of doing things in Glulx is that you just your save file is just the entire memory dump of the entire VM state. This is not something that really works well in modern system architecture. There's it doesn't really play well with Rust either. So text adventure is some kind of database engine that runs standalone. It can't have an OS dependency because we don't have an OS. We just have GLK. Is able to support undo, which means keeping track of game state after every turn, which is more involved than just checkpointing a transaction, being able to roll back, but once it's committed, it's committed. And finally, just for programmer convenience, we want some kind of decent query language, and not just a key value store. And I looked, and there is really nothing out there that actually satisfies these requirements. And so I've wound up building something, and but since this is actually going to become going to become a standalone project that Bedquilt depends on, but it's not part of Bedquilt proper. It'll be released separately so that it can be used in other domains. And it's going to be based on the entity relational model, which is a close cousin of relational databases, but not quite the same thing. Everything in this model is identified as either an entity, a relationship, or a property. An entity by itself is just a unique identifier. It's just a number that's distinct from any other number. The number doesn't have any intrinsic meaning. Relationships are binary relations between entities, and properties relate entities to just simple data types like strings. So, for example, if in your game you have a white house west of an open field, then the house and the field are entities. There's a relationship west that relates the house to the field, and then you would have some kind of vocabulary property that assigns the strings white and house to the house, and open the strings open and field to the field. And this is the database, but and you use these database primitives to represent the content of your world, and be able to manipulate that world in a structured manner, and checkpoint, save, restore, undo, redo. And interesting, and if any of you are fans of the game engine Dialog, being able to write these queries in relational algebra with a recursive closure operation is very similar to the kind of logic programming that you do in Dialog. And in fact, if you're familiar with database systems based on Datalog, it's a fairly similar thing, just unifying database programming with logic programming. And so this should make it elegant and straightforward to write queries for things like list all the objects in my world that are currently in scope visible to the player, even though that may be through looking recursively through several layers of things. So if you have if you have something inside a clear container that's inside your inventory, but perhaps multiple levels of containers within containers, be able to be able to elegantly write a query that shows you what's visible to the player and what isn't. So that being the current state of this development, I want to open things up to questions at this time. At this point, we've discovered we've discussed the low level completed aspects of the system. Everything from here is more aspirational, but since we've got plenty of time here, just what do people want to talk about?
Yeah, if anyone in the Discord wants to speak, you can raise your hand. And if any of you here have any questions, you'll have to come up here and ask the questions. Otherwise, yeah, we'll move on.
I was wondering, what approach are you envisioning towards writing a parser for this part?
Yeah. So I'm planning a fairly conservative parser design. It's probably going to look pretty similar to the Mercury parser in TADS, because even though it would be possible to innovate far beyond what interactive fiction parsers are currently capable of. But after giving it some thought for a while, just because we can doesn't mean we should. Parsing, so decades before we had LLMs, we already had we already had natural language parsers that could interpret sentences of far greater complexity than what parser-based interactive fiction currently understands. But that's not actually the hard part of the problem, because most English sentences don't make any sense inside in the context of an IF game. For example, if a user were to type into a game, most sentences don't make sense in the context of an interactive fiction game. Even if the game is capable of diagramming that sentence, what's it actually supposed to do with it? The challenge is not in parsing; it's in actually implementing the semantics of that sentence within the world model. And so I think our games are already pretty much at a happy optimum in terms of in terms of what the user should be able to expect to type into the system, and what the developer should expect the user to type in and have to deal with. So even though I could easily run wild with some fancy natural language parser in the game, it's not a good idea to do so. It's just going to make things more difficult on everybody.
Do you have any other questions? Okay, I guess we can move on with this switch. Do you want to end this?
Service then?
Do you want to end things up?
Yeah, I can take it out. It doesn't look like there's anything in the Discord, but yeah, if you want to call it, I think you're good. Yeah, thank you for your talk.
Cool. Great. Thank you.